AB Calculus, section 3.9, day number 1. We're going to review some logs and talk about the derivative of y equals absolute value of x. So what is a logarithm and why do they exist? Well, a logarithm is the inverse function of an exponential function. So the function y equals e to the x, its inverse, y inverse, is the natural log of x. So if I input an exponent, I get out a value, right? Some value. In this way, if I input a value, I get out an exponent. I spelled exponent wrong. Great. It's getting late. All right, so let's talk about and sketch an exponential function. We'll go with e to the x, and a logarithmic function, ln of x. So e to the x. All right, exponential functions that have no vertical transformations going on will have a domain of all real numbers and a range of numbers greater than 0. Okay, so what would that look like? Well, all exponential functions go through the point 0,1 unless there's a vertical shift or a vertical reflection. Okay, now the function y equals e to the x goes through a couple other points that we can note. Negative 1, positive 1. This would be the point 1e. This would be the point negative 1, 1 over e. Okay, so you can see the domains, all real numbers. You can see the range, 0 to infinity. So how does the domain and range of an exponential relate to the domain and range of its inverse, or its logarithm? So the domain of the logarithm will be 0 to infinity, and the range of the log will be all reals. So when I consider the logarithm, it's going to have a vertical asymptote at x equals 0. It's going to go through the point 1, 0. E1, notice how this is, I think it's just cool how this works, but 1 over e, negative 1, that because these are inverses, and inverses domains and ranges switch, right? So the domain of one is the range of the other, that the x and y values also switch. So this is the logarithm y equals ln of x, or log base e of x. Okay. So, and that would work for example, if I had y equals 5 to the x, then its inverse function would be y equals log base 5 of x. Okay, and same for any base. Okay, so let's talk a little bit about logs. Remember and consider y equals 2 to the x. What if y equaled 8? What if y equaled 16? What if y equaled 10? How do we figure out what x equals? Okay, so if y equals 2 to the x, what if y equals 8? Could I find the x value such that that's true? Well, there's a number of different ways I could figure this out. One way is I could write this in a base 2 form. Oh, so x would equal 3. All right, another way that I could do it is I could just take the, I could rewrite this in log form. So this would be log base 2 of 8 is equal to x, and then solve using my calculator. And there's a couple other forms or ways that I could figure this out. Of course, this would, if you didn't already know that 2 to the third was 8, you could use your calculator for that. But you really can't use your calculator for that. I mean, the older calculators you couldn't. Nowadays you can. But when we didn't have the ability to use base 2, we had to use this thing called the change of base formula. Okay, so the change of base formula, and I'm kind of skipping over some of this stuff, like if y equaled 16, then x would have to equal 4, because 2 to the 4th equals 16, so there's x equals 4. But like, how do we figure out, 10 is equal to 2 to the x? Because 10 can't be written as a power of 2. So we would write log base 2 of 10 equals x. And again, we need our calculator, but if we had an older calculator, how do we do it? Again, change of base formula. So if I have log base a of b, I'm allowed to write this as a quotient of 2 logs, and I can pick the base that I want. Okay, but the base has to be the same in the numerator and the denominator. So typically, the easiest way to do that is to pick base e. So log base a of b is equivalent to the natural log of b over the natural log of a. All right, so a logarithm is nothing more than an exponent. We showed that up here, right? It is a way to solve an exponential equation for the exponent. A logarithm is the inverse of an exponential. Okay, let's look at some more properties of logs, and then we'll look at a derivative of absolute value of x. Okay, here we are, some properties of logarithms. Log base a of a equals 1 because a to the 1 equals a. Now, this a right here is this a, right? I'm just writing in exponential form. All right, so in the next example, log base a of 1 equals 0 because a to the 0 equals 1. In the same way, log base a of a to the x is equal to x because a to the x is equal to a to the x. Okay, a to the log base a of x is actually equal to x. Okay, number 5 and 6 are closely related. One of them is an actual property. The other one is just there to fool you. But if I have the log base, well, what is the base there? That would be base 10 if you don't see one, of a times b. That's the same as log base 10 of a plus log base 10 of b. However, it doesn't work the same the other way. This is not equal to this. Okay, that is not equal. Therefore, there's no way to simplify that. Okay, division within the logarithm means subtraction of the two logs separately. Okay, this, I mean, what we could do is use the reverse change of base. Therefore, this would be log base b of a. And then in our last example here, if you ever see an exponent within the logarithm, you are allowed, by properties of logs, and again, if you want to see the reason why, you can check out a video I'll post later on bringing that exponent down in front as a coefficient. Okay, so what is a natural logarithm? The natural logarithm is the log of base e. Okay, it's never written that way. We just identify it as the natural log of x. So what is the natural log of e? Well, since this is base e, that means e to the x is equal to e. Okay, so this e is this e, and this e is this e to the x. Okay, so clearly this is e to the 1, so natural log of e is equal to 1. What about the natural log of 1? Well, if I wanted to figure out what x is, then that means e to the x equals 1. Thus, x, or the natural log of 1, should equal 0. Okay, so let's look at, this will be our last couple of examples for today, at least for this video. Find the derivative of the absolute value of x. Now, the absolute value of x can be defined as the square root of x squared. Okay, so by definition, that's probably not something you've seen very often at all, but that is the definition of the absolute value. So if y equals the square root of x squared, and I'm going to rewrite that actually as x squared to the 1/2. Now don't simplify that. I don't want that simplified. I want to use it in that form. Then y prime would equal 1/2 x squared to the negative 1/2. And using the chain rule, I then multiply by the derivative of the inside. So let's clean that up a little bit. You'll see that the 1/2 and the 2 reduce. I'm going to bring the x squared to the negative 1/2 to the denominator. So that would be x over the square root of x squared. Okay, now I know that the square root of x squared is equal to the absolute value of x. So y prime is equal to x over absolute value of x. So if y is equal to the absolute value of x, then its derivative is equal to x over the absolute value of x. That's actually really cool. Okay, so now let's look at y equals absolute value of sine x. Now I could go through this whole process that I did here, right? Writing that as sine x squared to the 1/2 power, or I can just use this model right here where sine x is equivalent in nature to x. Okay, so if I took the derivative of the absolute value of sine x, I should get sine x over the absolute value of sine x, but I'm missing something. By using the chain rule, I'd have to multiply by the derivative of sine x. Therefore, y prime would equal sine x cosine x over absolute value of sine x. Now, how come that cosine x came along? Like, I don't see, because I see sine x over absolute value of sine x. That makes sense. But cosine x, well, if you consider this over here, what's the derivative of x? Well, it's 1. So technically, the 1 plays the same role as the cosine x. It's the derivative of that inner function. Okay, and that's what you get, guys. That is the derivative of absolute value of sine x. All right, hope you guys have a great evening, morning, middle of the night, playing Thrones and games and whatever you guys do, or Minecraft. Boy, it's getting late here, so I'm going to get going, but I will see you in the next video.